Alright, today we're going to be doing exponential functions. Now, we've done quadratic, we've done linear. This is the last type of function that we're going to be learning about in Math 1. I don't know if you should have known anything about this beforehand, but if you didn't, it's going to be a review or it's going to be new to you. So, exponential functions, they increase or decrease at a very fast rate. Okay, so think about things that increase very fast or decrease very fast. That can be modeled by a graph such as this. This would be increasing at a very fast rate. So as you see, as the x is going up, the y goes up even faster. Once it hits a certain point, it's going to start going up really fast. Same with the decreasing. It would decrease very fast and then it will level off. Okay, those are the models of what an exponential function looks like on a graph. Okay, this is the actual formula or the way they write exponential functions. If f of x, or we can plug in y. F of x is the function of x, or there could be a y here, as you'll see in the examples, equal to a times b raised to the x power. So now this x is no longer on the bottom, it's raised to the x power, which makes this the exponential, because this x is now the exponent. Okay, that's why it's called an exponential function. Below, a is called the initial value or the investment amount. A lot of word problems and EOC type problems that they're going to give you are going to deal with either money or some type of scientific problem. You'll see this in biology next year, or maybe even in earth and environmental, where you'll have exponential type functions. Okay, so the initial value or the investment amount is what will normally be right here for A. The f of x or the y, like I said before, is the final or total amount left. Okay, so if it's a decreasing problem, it's a half-life, a decay. Growth and decay models follow exponential functions. So if it's a decay, it will be what's left after it decays over so many years. If it's a growth model, it'll be what's left because it's increased. Okay, so this is either going to increase or it'll decrease really fast. So those are all the kind of general things about exponential functions. Again, A is the initial amount. We're going to talk about B right now. To determine the rate or the B, so the B is the rate of change, when it isn't provided for you. Okay, so that B is not given. They may give you a percent. Okay, this is why we practice percent to decimal, decimal to percent. You're going to change the percent to a decimal. Okay, if it is a growth problem, and you're going to have to read within the context of the problem to determine, is it a growth or is it decay? Is it going up or is it decreasing? If it is an increased problem and it's growing, you're going to add 1 to that decimal. After you change the percent to a decimal, you're going to add 1 to that decimal. If it's a decay problem, you're going to do the opposite, which is subtracting 1 minus that decimal, whatever the decimal is. So you're either going to add 1 if it's growth, you're going to minus the decimal from that 1 if it's decay. Okay? Then you're going to put this value into the equation for B. So this is all for the B. Okay, the B is the rate. If they give you an interest rate, you're going to need to determine, is it growing or is it decaying? And then based off that, you're going to either add 1 or subtract it from 1. Okay, so B, this B might be R. They may tell you what the rate is determined based on what's in the problem, but you'll have to determine what is the B for that problem. Okay? We're going to do some practice with this, but make sure you know how to change percent to decimal before you move on to the next step. Okay? When the values of B are greater than 1, the function will increase. So like on that first graph that I showed you, where it was going up, the B value had to be greater than 1. Okay, so if it's greater than 1, the function will increase from left to right. Okay, but when the values of B are less than 1, but greater than 0, so think about what type of numbers those can be. If it's greater than 0, so on my number line up there, if it's greater than 0, it may be a fraction. And if it has to be less than 1, it's definitely going to be a fraction, like 1/2 or 1/3 or 3/4 or 2/3. It's going to be a fraction. And again, fractions can be changed to decimals. So if you see a decimal, the function will decrease from left to right. So if your B value ends up being a decimal less than 1, but greater than 0, that function you know is going to decrease from left to right. Okay, so think about numbers that are in between 0 and 1, which are all decimals or fractions, like 1/2, 1/3, 2/3, 3/4. or 0.75, 0.25, 0.5, 0.33 repeating, all of those numbers or values would decrease going from left to right. Okay, so you'll have to have some number sense in going into exponential functions. Alright, so now we have our practice, and we're going to throw this up here. Not what I wanted. Okay, so practice with this. Rewrite the following statements into the b values that would be used in the equation. So, if I were to increase, this is just solving for the b. If I were to increase by 3.5%, okay, that's percent. First thing, as the 2 slides ago said, you already had this in your notes. To change percent to decimal, you should already know how to do. We're going to move that decimal over twice. Okay? And then it says increase. So if I'm increasing it, is that a growth or is that decay? You'll have to figure that out. If it's going to be increase, we're going to be growing. So we're going to need to add 1 to it. So our first, if you should already have an idea of what this value is going to be, if we're growing by 3.5%, we're going to change that to a decimal, and that decimal is 0.035. Then we just add 1 to that decimal. So if we were to increase, our b value would be 1.035. That is increasing at 3.5%. Okay. If we were to decrease, okay, so now we're decreasing. This is decay. Decrease, decay. Hopefully you can remember it that way. Decreasing by 6%. We're going to change this percent to a decimal. Now the decimal is not visible like it was in number 1, but it's behind the 6. So we're just going to move that over 2 times. So our decimal is going to be 0.06. Then we do, because it's decay or decrease and decay, we're going to do 1 minus that 0.06. When we do 1 minus 0.06, we should get 0.94. Okay, so that is the b, or the rate that I would plug into the formula for my b. Right? The last 2, hopefully you've already done. Increase by 0.25%. So now it's 0.25%. We still need to move the decimal over because this was a percent. We need to change it to an actual decimal. So we'll move it over 2 times again to get 0.0025. And we're going to increase it, so we need to add 1 to it. So when we add
Mr. Moore to the main office, Mr. Moore.
When we add 1 to it, we get 1.0025. Okay, that's increasing it. So if it's increased, you should always have a 1 out in front. For the decrease, change the percent to decimal, move it over 2 times, and then we should get 0.9525. Okay, we get that because we're subtracting this after we change it to a decimal, subtracting it from 1. Okay, so those are just practice problems with changing our percent to decimal and determining is it the growth or is it decay. That's only half of the problem. That's only half of what you'll have to do with these exponential functions. Okay, so there we go. Given, this is what an exponential function is going to look like. They may give you this on the EOC, but this is kind of hitting all areas of exponential functions. Determining is it growth or decay, what's the initial value, what's the rate, and being able to evaluate giving some time or some x value. Alright, so given this equation, y, so now we have y, f of x, y, same thing. You could have f of x here if you want to. Y equals 225 times, in parentheses, 1.23 raised to the x power. That x needs to look like an exponent. If it is not an exponent on your paper, and it's on the same line as your 1.23, I know that you don't know that this is an exponential function. You're just writing x down on your paper because that's what's on the problem. You need to make sure I recognize that this x is the exponent. Okay? So, does this equation represent growth or decay? To determine if it's growth or decay, I need to look at that b value. So, initially, the very first slide we had was our function or our formula, a times b raised to the x power. Okay, so determine what my b is. My b, if I looked in parentheses, is 1.23. We just practiced changing those percents to decimals based off if it was increase or decrease. So if it's increasing, we had a 1 in front of our decimal. For my b value here, I have a 1 in front of my decimal, so that is going to be a growth problem. Okay, so this value would be growing. And you'll see why we do this when we get to money, talking about interest rates, stuff that you'll need later on in life. Okay, y'all always ask, when am I ever going to use this? This stuff you will use, or you at least need to have some type of background knowledge on. Okay, so this is a growth problem. What is the rate of growth or decay? So this is where we will need to solve for the b. So if I'm given this is my b, so b is equal to, what happened here? Okay, I'm given b is equal to 1.23. And I know it's a growth problem. So I added 1 to this. I want to know how can I find that percent that it grows by. So if I subtracted 1 from this, because I know it was a growth to begin with, I can subtract 1, and when I subtract 1, I'm left with 0.23. Now I want to change that decimal back to a percent because I need to have the percent of increase. So to change it back to percent, I'm going to take that decimal, move it back to where it should be, and then I would get 23%. Now because it was a growth problem, I knew it was growth, I knew I had added 1, so you're just working backwards. I had added 1 within the problem. Now to find that rate, you have to work backwards. So I take off the 1, and then I move that decimal back. Okay, so you're just working backwards from what we did 2 slides ago, finding the rate. Now you're finding the percent, so you're going backwards. So to go backwards with a growth problem, you subtract 1, move your decimal over. So our growth was 23%, so my b is 23%. What is the initial value? This is easy. The initial value, remember, is a. So my a is 225. And then evaluate. Evaluate in math just simply means plug in. So I'm going to plug in for x equal to 2. I'm going to plug my x in right here, or my 2 right here for the x. And remember, this is an exponent, so you can't just have 225 1.23 times 2. You need to raise that with the little caret button on your calculator like this. Or you could square it because it is a 2, but you need to have raised to the second power. So all of this, or this 1.23 needs to be raised to the second power. Okay? So type that in like you see it with just a 2 right here in place of the x. When you do that, you should get y equal to 340.40. We'll round to the nearest hundredth. 2 decimal places behind the decimal. So we got 340.40. That is all the parts, kind of the basics of exponential functions. Stuff that they're going to ask you on the EOC. They may ask you in a word problem, is this growth or decay? They may ask you the rate. I know they'll ask you the rate because that's always the hardest part to find. Subtracting 1, moving it over. What is the initial value? That's easy. That's just knowing what A stands for. And then evaluate is just plugging in the number for X or T because they like to use time for T. So that is all of example number 1. We'll move on to example number 2, which is a decay problem. So we did 1 growth, we'll do 1 decay, and we'll go from there. Okay, so I already told you it was going to be a decay, so does this represent growth or decay? And how would I know this is growth or decay? By looking at my b value. If it's less than 1 and greater than 0, like I had in that slide talking about the graph, when it's less than 1, which 0.57 is less than 1, and greater than 0, it's still greater than 0. It's not a negative number. When it's less than 1, greater than 0, I know this is going to be a decay problem. Okay? So that b value is what I'm looking for and determine if it's growth or decay because I want to look at the rate at which it's growing or decaying. So what is the rate of growth or decay? So we know for decay problems, I do 1 minus the b, and b or the rate. And that's going to be equal to that decimal. So if it's 1 minus this, I'm going to plug in for my b what it was. So I'm going to do 1 minus 0.57 because it's decay. So just like I did minus 1 for growth, now I'm doing the opposite because it's decay. I'm going to subtract the b value. Okay, so 1 minus 0.57 is 0.43, And again, you need to move that decimal over to get the percent because they want the answer in percent. So to change that to percent, move the decimal over twice. So my B value is going to be, the rate of growth or decay is going to be 43%. So always have, when they ask for the rate of growth or decay, always have it in percent. So you need to know how to change decimals to percents and percents back to decimals. Part C, what is the initial value? Very easy. Look at the A value. The initial amount, the initial investment, if it's money, the initial value for this problem is 35. And then part D, that's just plugging in. Evaluate means to plug in. So I have x equal to 5, so I'm going to plug in 5 for my x. And when I do that, I should get, I believe, y equal to 2.11. Which makes sense. Because I said this was a decay problem, it's decreasing. So if my initial value was 35, I shouldn't have anything for y greater than 35 if it's decreasing. Okay, so if you got some number greater than 35, it's not making sense. If it's a decay problem, you need to make sure that it's decreasing. Your values are decreasing at a very fast rate. If I look, I only went down 5 times, but look how far it went down. It went from 35 to 2.11 in just 5 x values over. Okay, so it's decreasing at a very fast rate. So make sure your answers are making sense within the context of the problem. Okay, so that is all the decay. Excuse me. That is all the decay stuff that they will ask you. So you have to recognize if it's decay, you're going to have to subtract your B to find the percent at which it's decaying. If it's growth, you're going to have to subtract the 1 off of it to find that rate of growth. Rate of growth, the growth rate is always easier to find because you just subtract 1. You just take whatever's behind that decimal and change it to the percent. The decay is a little harder because I have to subtract this from 1 in order to find the actual percentage. Okay, so that is an example for decay. Now, the last thing is a word problem that you will need to copy down, and you can do this on your own. You're going to answer this completely. Okay? It said Raymond invested $4,000 in a new company. And just be writing this down as I'm talking. The value of his investment has been growing at a rate of 6% per year for the last 5 years. The function, so here's my function, A equal to 4,000 times 1.06 raised to the t. It represents the growth of his investment of $4,000, where A is the total value of his investment and t is the time invested in years. What is the total value of his investment after 5 years? Okay, that's a lot, but they told you and they broke it down for you if you simply read what you need to know in this problem. Okay, after you copy this down, you're going to want to annotate because it's a lot of words and there's a lot of stuff in here that I need to know. And I'm going to help you through this. It said Raymond invested $4,000 in a new company. Now, back to my original exponential function, I have y equal to a times b raised to the x. We said a is the investment amount or the initial value. Well, it just told me he invested $4,000. So I already know this a value, this is a lowercase a, is going to be 4,000. The value of his investment has been growing. They just told me, is it growth or decay? At a rate, and they told me the rate. So I know my b value. I would simply have to change my b to a decimal. For the last 5 years, the function a equals 4,000 times 1.06, so they even made the function for you. They already gave it to you, but you need to know what the parts mean. 4,000 times 1.06 raised to the t, that's a lowercase t, because they use t for time, I believe, later on in the problem. Represents the growth, so again, they told me it's growth of his investment of $4,000, where a, so this big K, this uppercase A, is the total value. And like I said, this is not y or f of x, but they used a in place of y. So this is the total value of his investment, and t, they told me what t represents, is the time invested in years. So we don't have x, we don't have y, we have a and we have t. But if you don't annotate, you may get confused. So you need to annotate these problems and be able to understand, okay, this is my a, this is my t, and this is what my initial value was, and this is my rate. Okay, what is, and here's the question, the most important part. What is the total value, so what is A equal to, of his investment after 5 years? So there they gave me my time value. Okay, so I know what I'm going to plug in for my T. Alright, so circle 1, is it growth or decay? Well, if you just read and you know how to read, you can see that they use the word growth and growing in the problem. So that's an easy one. It's going to be growth. What is my rate? Well, if you read, they said the rate was 6%. I want you to change that to a decimal. 6% change to a decimal. I take that decimal right here, move it over twice, and I have a decimal of 0.06. Makes sense because that's what they have in the equation they gave me, 1.06. Okay, and my initial amount was 4,000 because that is what the investment amount was. Now, to answer the question, you simply plug in evaluate. Remember that word evaluate. You're going to evaluate this equation for 5 years. So if I'm given A equal to 4,000, 1.06, instead of T, I'm now going to have 5. You simply type that into your calculator